Hello everyone. So before we start with today's video, let us discuss what we have covered so far, what all kinds of activation functions we have discussed so far. So we begin with sigmoid and tanh activation function. We learned about all their advantages and disadvantages, and after that we developed a new activation function that was called ReLU, and ReLU tried to solve the problems which are faced by sigmoid and tanh. But now ReLU was also facing some problems, and the problem was of dying ReLU. So in order to deal with dying ReLU problem, we discussed further three new activation functions which were basically the variants of ReLU. So their names were PReLU, Leaky ReLU, and ELU. And we also discussed that whether in practical implementation, whether these new activation functions solved the problems of ReLU or whether they were actually better than ReLU or not. So after that, we covered a new activation function. After that, we dealt with a new activation function that was GLU, or gated linear units. So that was all the different kinds of activation functions that we have covered till now. And in this video, we will be learning three brand new activation functions, which are Softplus, Maxout, and Swish. So without wasting any time, let's get started. So let us start with Softplus activation function. And if we talk about Softplus, then the first thing that should come to your mind is that Softplus is an activation function whose graphs looks very much similar to that of ReLU. So its graph is very much similar to that of ReLU, but actually it is smoother. Suppose this is the graph and the red line here is the graph of ReLU. So here you can see that ReLU's graph is not smooth. And at 0 it is not differentiable because the graph is not smooth at 0. But if we talk about Softplus activation function, the graph of Softplus activation function, then its graph will look something like this. From this you can see that the graph of Softplus looks very much similar to that of ReLU, but actually it is, we can say, or we can visualize it as a graph that is smoother to that of ReLU. Now let us discuss the second point. The graph of Softplus is is smooth and differentiable at 0. And if we take the derivative of the Softplus function, so this is the function of Softplus ln, and inside ln there is 1 plus e to the power of x. So basically we are taking the log of 1 plus e to the power of x, where x is the value that you will be getting during the pre-activation step. And if you differentiate it, then you will get this function, which is basically your logistic function or the sigmoid function, and its acceptance range is between 0 to infinity. So just like ReLU, it will give you values between 0 to infinity, but unlike ReLU, its graph is smoother. Its graph is smooth at 0, at x is equal to 0. Now let us discuss Maxout activation function. So the formula of Maxout activation function is maximum of between this one and this value. From here you can see that its formula looks very much similar to that of ReLU. So basically ReLU is a generalized, or I can say ReLU is a special case of Maxout. We can say that Maxout is a kind of activation function that tries to generalize ReLU as well as leaky ReLU. So yeah, both ReLU and leaky ReLU are special cases of Maxout. So since ReLU as well as leaky ReLU are the special cases of Maxout, therefore Maxout activation function possesses all the advantages of ReLU, as well as it does not possess the disadvantages of ReLU. So the disadvantage of ReLU was a dying ReLU problem, and since Maxout also contains the portion of leaky ReLU, therefore Maxout function deals with the problem of vanishing gradient. So it has basically all the advantages of ReLU, and because since it has properties of leaky ReLU also, therefore it tries to prevent the dying ReLU problem. So yeah, it has benefits of both the worlds. Now let us discuss our last activation function, the last activation function for today's video, which is Swish function. And a Swish function is also known as a self-gated activation function. If we talk about its graph, then if we compare it to that of ReLU, then the graph of ReLU will look like this, and the graph of Swish will look something like this. So here you can see that the graph is smooth at 0, but also the graph is non-monotonous. The graph is also non-monotonic. It means that at some portion the graph goes in some direction, and in some other portion the graph goes in some other direction. So here you can see that the graph looks something like this. In this particular region, the graph first increases, then decreases, and after that the value decreases. So this is a swish activation function. It has a smooth function, but also the graph is non-monotonic. That is, the graph does not remain stable or move in one direction. Now let us discuss how swish activation function is actually better than ReLU. The first point is that the graph contains sparsity. That is, the extreme negative values, the values that are extremely negative, are zeroed out. So here from this graph, you can easily observe that for extreme negative values, the value of the graph, the value of the function is 0. For very negative weights, for very negative values, the values are simply zeroed out. The second benefit is that just like ReLU, for the positive portion, there is no saturation. That is, there is no limit. For the positive values, the value of output is similar to that of the input. So yeah, for very large values, the output do not saturate to the maximum value. And the third advantage is that basically ReLU was facing the dying ReLU problem. That is, for the negative values, the output was 0. But here, for small negative values, you will get some output. Extremely large negative values will be zeroed out. But for small negative values, for example, this section of the graph, you will get some output. So because of that, the swish activation function does not possess the dying ReLU problem, and also because for small negative values it gives us some output. Therefore the neural network that has swish activation function is also able to analyze the patterns where the output from the pre-activation step are negative. So that is the benefit of swish activation function. So that was all for today, guys. In this video we learned everything you needed to know about Softplus, Maxout and Swish. And in the next video, we will be learning about mesh activation function. So we will meet in the next video. Until then, bye bye.